Welcome back, ladies and gentlemen. Today I'm going to go over lecture 1.4, electron configurations and the octet rule. To start you off, I'd say the best thing to try out would be this build an atom simulator, courtesy of PhET Colorado. You can find the website right down here, http://phet.colorado.edu/en/simulation/build-un-atom. If you want to complete the worksheet, you can find that on my website. Just let me know if you need any help. Today's learning target is learning target 1.4. I can determine the number of valence electrons for an element, draw a Bohr electron configuration for an element, and explain how the octet rule leads to the formation of ions. These are three somewhat difficult skills, so I want to go over them in as much detail as is necessary. First things first, an essential point you have to know is that atoms do not have any charge. The reason they don't have any charge is because atoms, neutral atoms in particular, have an equal number of protons and electrons. If your positives for your protons and your negatives for your electrons do not equal each other, you are not neutral. So when we look at atoms on the periodic table, they are always neutral. Therefore, atomic number also tells us the number of electrons. So when we see atoms on the periodic table, such as oxygen, which has an atomic number of 8, like that, we know that oxygen has 8 protons and also 8 electrons, given that any atom that appears on a periodic table is a neutral atom. The next thing we should know about the periodic table is that it is arranged into groups, which are vertical columns, and periods, which are the horizontal rows. A good to remember that is that periods push across and that groups go down. In high school, my science teacher always taught me groups, pyramids. Groups, periods. Did I say pyramids the first time? Excuse me. Groups and periods. If you want to look on a periodic table, it appears sort of like this. And here we have our groups which go up and down. Group 1 and group 2. 3 through 12 right here. 13, 14, 15, 16, 17, and 18. Sorry that's not drawn as appropriately. But these are the specific groups since they go up and down. Now, periods go across and appear like this. Not the best artist. I don't have a ruler, so apologize. So I apologize for this, but here's what the periods look like. And periods go 1, 2, 3, 4, etc., etc. as well. These will have important ramifications that we'll discuss in our next lesson. So here's our periodic table, broken down into groups and periods. And from this, we can take atomic numbers and determine the number of protons and electrons. Given that we know the number of electrons in any atom we can find in the periodic table, we can draw what's known as Bohr structures, which sort of appear like this. This is what the Bohr model of the atom states. Remember that Bohr, Niels Bohr, was the gentleman who discovered that electrons do not roam freely. In fact, they are assigned to specific, what he called electron orbitals around the nucleus. So if we have 17 protons here, we expect to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 electrons. And remember, the valence electrons are the one on the outside. And here we have 7. So, knowing that the first orbit holds 2 electrons is extremely important. And as we see in our previous example, 1, 2, the only number of electrons that we can fit into this first orbit. You cannot put electrons in the second or third orbit until the first one is completely filled up. It's like a really cool concert. the best concert of all time. In the middle, we have Shakira playing to Mr. Astor. Mr. Astor and his brother are going to sit in the front row. And the only 2 people that can fit in the VIP front row. After that, we have 8 people that fit in the second row, 8 people that fit in the third row, and 8 people that fit in every other orbit after the first. They hold 8 electrons. So remember, 2 electrons on the first one, 8 electrons on every one afterwards. Now the ones on the very most outside are known as valence electrons, as I stated a little bit earlier. Valence electrons, the number of electrons that are in the outermost orbit. So if we look here again, we see that we have 17 protons. Only 2 electrons can fit in the first row. 1, 2, 3, 4, 5, 6, 7, 8 in the second orbit. And 1, 2, 3, 4, 5, 6, 7 in the last orbit, indicating that we have 7 valence electrons. Now it's not 8 because we don't have enough electrons to fill this last outer shell, but if we did, we would fit 8 and then we move into the next shell. So remember that valence electrons are the electrons on the outside. Give this a shot with some of our examples. Here's a good class example, drawing the Bohr electron configuration for lithium, which you can find the answers in some of my other YouTube videos. Draw the Bohr electron configuration for sodium. You can find the answer for that one as well. And potassium. If you have any questions, just ask me where to find them. A good shortcut to remember is that all elements in the same group, that's group 1A, 2A, 3A, 4A, whatever it may be, have the exact same number of valence electrons. So, any element in, say, group 2 is going to have 2 valence electrons. That means 2 electrons on the outside. An example looks something like this. We have our nucleus here. We have our first valence shell, our second valence shell. We're not going to count helium as being part of group 2, since helium is a noble gas. Say we put 2 there and 2 there, that's 2 valence electrons. Now, if we were to fill this shell up and add another electron shell, and put 2 more there as well, this would also be in group 2 and also has 2 valence electrons. The first one I drew happened to be beryllium, and the second one happens to be magnesium. Both group 2 elements. So go ahead and take a second to summarize that for me before we move on to the next section. Go ahead and pause this right now, write your 3 to 4 sentence summary. Remember to include what are valence electrons, how many orbits fit in each orbit for any atom diagram, and what do we know about atomic number given that every element on the periodic table is said to be neutral. Now, moving on, we have the octet rule, and the octet rule is extremely important to chemistry. It determines everything that happens in the world and how all reactions proceed. Atoms always like to have a full outer valence shell. So they never like to have less than their full amount. They will gain or lose electrons in order to have an outer orbit with 8, because remember that all orbits except the first one want 8 electrons. If you're in the first energy level, 2 is fine as well, because that's how many fit in the first row, just 2. They're going to gain or lose electrons based on whatever is easier for them. So if they need to gain 2, they'll gain 2 instead of losing 6. Or if they need to gain 1, they'll gain 1 instead of losing 7. Or if they need to gain 3 instead of losing 5, they'll do that as well. Sometimes even they'll just lose electrons. They'll lose 2 instead of gaining 6. You can find a few examples of that. Here's the first example of beryllium, drawing the Bohr electron configuration for beryllium after it has satisfied the octet rule. And you can find the answers to some of these questions in some of my other YouTube videos. You can also do the one for magnesium after it has satisfied the octet rule, and practice drawing the Bohr electron configuration for calcium after it has satisfied the octet rule as well. All elements in the same group have the same number of valence electrons, which means that they also gain or lose the exact same number to satisfy the octet rule. Now the last thing you need to know are ions. Ions are what happens when an atom gains or loses electrons to be happy, to satisfy the octet rule. Now when you gain electrons, you're going to add more negatives, meaning that you're going to become a more negative atom. Or if you lose electrons, you're going to lose negatives, meaning you're going to become a more positive atom. Now, we call these ions. When they gain or lose electrons, they become an atom or molecule where the number of protons does not equal the number of electrons, giving the atom a negative or positive charge. If it's a positively charged ion, we call it a cation. If it's a negatively charged ion, we call it an anion. How can I remember that, Mr. Astor? Here's how I do it. Cats make Astor feel very positive. Look at how cute these kitties are. Kitties are adorable. Remember, the cats make Mr. Astor feel very positive. If it helps you, imagine Mr. Astor petting a kitty in his hands right before he goes to bed. They make him feel very, very positive. So here, I want you to try out determining the ion that would form for fluorine after the octet rule is satisfied by drawing the Bohr electron configuration diagram, adding or subtracting the appropriate number of electrons, and finding out how many negatives it has gained or lost. If you want to find the answers, you can find them in some of my other YouTube videos as well. Try the one for nitrogen and for oxygen before you have finished this lesson for the day. Now, a good shortcut to remember is that all elements in the same group, be that group 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, all form ions with the same charge because they gain or lose the same number of electrons. So this is a great little shortcut chart to keep track of. Go ahead and summarize that for me in 3 to 4 sentences, remembering to include the octet rule, what ions are, the 2 different kinds of ions, and why things do the things they do. Here's some extra practice, guys. Get a little rally coach going on if you can find a partner. Try to draw the Bohr electron configuration for neon, sulfur, phosphorus, and magnesium. And if you feel like you're ready to go, the exit ticket is right here. When you finish this lesson, go ahead and grade yourselves on your learning targets 1 through 4, learning target 1.4, and the ones previous, as always. This is the end of our lesson. I hope this helped. If you want some homework or some practice, go ahead and try homework 1.4 on the octet rule and the Bohr structures. We'll have a quiz on all of the learning targets up to this point coming up soon. Hope this helped.